Another draft physics presentation. Alright, so I just want to update this video with the other version of the experiment that's done with radio waves, so I figure I'll just kind of go over that one again and give a rational explanation for the outcome, and just emphasize this is an experiment that can be done. And prove it one way or the other. So just finding the person. I mean, it'd be best to find somebody that already has the equipment to do the experiment than me to buy it for one experiment. But yeah, we'll see how things go. If nobody else is ever going to do it, then I'll do it, just to demonstrate on one level that here's their explanation, here's the provable truth that it doesn't happen the way they claim it happens. And just to point the credibility finger and point out how they could be wrong about that conclusion, then they could be wrong about some of these other emphatic statements they make about what is happening in these experiments. So another issue came up in the comments regarding, by the way, comments. Look, if you can't handle the lying thing, if you can't refrain from lying about what I've said, then don't comment, because I'll record your comments. If there's any points you make in them, I'll respond to the points, but you're not going to post lies on my videos. So go ahead and do it. I'll block you, delete your comments, and that's it. But I don't have to accept that shit. So it's not that complicated. Not lying is not that difficult. So to pretend that you can't help it is just bullshit. Anyway, I'm being just rude, gratuitously rude. I mean, there's absolutely no reason for me to accept that. None. Zero. Anyway, I mean, you just don't understand how the roles work here. You're a commenter. You have to be the one who exercises some discipline, not me. But whatever. Alright, so the issue that somebody brought up was, I mean, I've talked about this before, but I just wanted to emphasize that I'm not contending that in the two-slit experiment you have two exact single slit patterns that just shoot out and they superimpose on each other. And the interesting thing is the guy whose video I linked to in the last comments video, Info Philosophy, I think it was called, he did a diagram that was just kind of deceptive in that he drew the single slit and then compared it to the double slit, and he sort of implied, like, when you have two slits that somehow the center is going to get radically changed. And it really doesn't. I mean, this is a tiny distance here, much smaller than the target you could ever even decipher out of this target. So you have to sort of understand that this is a ½ inch across, and this pattern up here is going to be, for the central maxima, might be 1 inch across. And so any differences here are all going to end up in this same center. You're never going to be able to distinguish between this exact center for this slit and the exact center for this slit. Those are going to be undecipherable at a distance. So that's sort of just irrelevant. So what I have contended is that in the double slit experiment, the single impediment, that can be just the single needle, and you'll still create the pattern. So let's understand that you'll create a pattern. You won't create the pattern. So the single impediment doesn't create the envelope. Which again, this envelope is such a deception because, as shown, the single slit pattern is quite complex. It has a lot of elements in it. So it doesn't come out like this unless you make it a specifically very narrow slit. So unless the slit's incredibly narrow, that's not going to be your pattern. And so anyway, so my argument is that the narrower this thing gets, that is, the smaller you make the single impediment, the more likely that there's going to be involvement from the charge element. The idea that the electrons are under pressure from, as I've pointed out, from the encroachment of this space by the surfaces, these atoms. And these atoms are going to start dominating this space, controlling it. And likewise, inside the material, that is the impediment, the same process takes place. There's a communication between one surface and the other surface, in the sense that if some sort of electron pressure increases on one side, it's going to be transferred to the other side through the atoms. So I'm saying the two-slit pattern is a composite of the circumstance of the two slits. The circumstance of the fact that you're now communicating the signal through this buffer. So when there's just a single slit, the buffer is just the atmosphere. When there's the double slit, there's a buffer that's a piece of material that's in between. And that buffer is going to be different than an atmosphere as buffer. Just as if this was voltage, it would be 10,000 volts across here, but it would only be 5,000 volts across here. So this surface is a 5,000 volt surface. These surfaces are 10,000 volt surfaces. That kind of thing. Alright, but I've been over that before, but I just thought I'd make that clarification. I also thought that it would be interesting to see if there was any version of the experiment that was actually done in a vacuum. So I was thinking I might have some old vacuum tubes I might try to find and see if I can find one that has something like a slit inside of it, you know, lots of little metal bits and stuff. Maybe one of them has a little place where you could shoot a laser beam through and do the two-slit experiment in a vacuum. So I couldn't find any online, like a bell jar, you know, where they put the two-slit experiment inside the jar, and then you could just shine the light into this experiment, and then you'd get the results out, and the key function would be in vacuum. It would be curious to see if there is any difference regarding the medium between the two slits, whether it matters whether there's an atmosphere in there. Okay, so that's enough on that. So we'll move on to the radio wave argument. Like I said, for some of you, I've already made this argument, and so it might be redundant. I just wanted to make sure it was part of this series of videos. So the idea is you can use either radar or regular radio waves. So we'll just draw it as an ambiguous signal producer. And the idea is you have two transmitters tied to the same source, so they're at exactly the same waveform they're producing, whatever frequency that is. So it could be gigahertz for you know, 5 gigahertz or whatever for microwaves, or something like that. 25, that doesn't matter. Or it could be a radio signal, an AM signal, 500 megahertz or something. Anyway, I guess that would be FM, but it doesn't really, you get the point. 75 megahertz, something like that. AM. It doesn't matter. So all you're doing is producing a radio signal. So let's just call for the sake of the argument that microwaves are just a form of radio waves. Oh, okay. Get it in the camera, Gary. All right. So it's tied to the same. They're both being fed by the same transmitter at whatever, you know, 10 watts or something. You need a strong enough signal to do this experiment accurately or correctly. Do it wrong, you don't need a strong signal. To do it right, you need a strong enough signal. But anyway, so the idea is there's two radio waves being created, and they have exactly the same phase. So exactly what's on this one is on this one. And what they do is 1,000 times a second they interrupt the signal. So it's being turned on and off. A little switch here. 1,000 times a second to put an audio signal onto this signal. That is, if you can receive this signal and you receive more than a second of it, you could decipher that there's an audio track on it and play the audio. But you have to first be able to receive the carrier signal. So first you have to be able to tune in the station. And that's the key problem with this experiment. So their argument is these two waves do the same thing as the double slit experiment, and that they interfere with each other, and they create on and off and on and off and on and off pattern. So you get the same on and off pattern. Okay, you can receive the signal, you can't receive it, you can receive it, you can't receive it, and it's in this some sort of strongest here, and then off, and then on, and then off, and you know, like the same bullshit. So sorry, the same. I mean the same. You know the routine. I would argue that the only reason why this part is off is because you have both signals out of phase coming to this location. So because of the separation in distance, the two distances to this location are different, and what happens is the two waves, waveforms, are exactly some degree out of phase. All right, maybe exactly out of phase, but some degree out of phase. So that means that the signal's strength is in this case, it would be no signal. It would be a flat line when they're exactly opposite each other. And if they're a little bit out of phase, the signal could look something like this. In terms of if you quantized it, if you turned it into a signal of, where you broke it down. And that signal wouldn't be received by the receiver as the signal you sent. So if you were this combination of two signals, okay, can't be received by the receiver as, say, 500 hertz. If we just said it was 500 hertz for the hell of it, it's going to see this as 1000 hertz, not 500 hertz. And so it's going to go through the band pass filter, and the receiver is going to say, I don't see anything, nothing there. So it's just jamming. So essentially, in this case, the two signals are just going to jam each other. Now, the simple experiment that can be done, I've seen it done, not for this purpose though, which was the unfortunate part. I mean, to demonstrate something else, so it wasn't doing the two transmitter circumstance. It was just doing a single transmitter. So the simple proof of this experiment, instead of having the sound wave, the on-off 1,000 times carrier, it's not a carrier actually, it's something else, but the point is where you have to first receive the signal to be able to pull the soundtrack off, instead of using that as the way you test whether the signal's on or off, because it really is just jammed, not jammed, jammed, not jammed. That's all this is. So the simple test is to have your two antennas produce your signals tied to the same frequency as before, and just have it at a high wattage. Send out a really powerful signal. Okay, and microwaves can probably do that without much trouble, but you obviously don't want to be exposed to them. And see, the problem is I've seen people do this with a microwave detector, but a microwave detector is going to do exactly the same thing a radio is going to do. It's tuning to a specific range of frequency. So as soon as you jam the signal, even though the microwaves are there, it's not your receiver is not going to be able to receive them because it can't interpret the data correctly. So what you really need to do is just have a regular antenna, just an antenna, and you just measure the potential across the antenna, and you move the antenna from across this field. You just move it across this field, and you have a meter, and you just measure the voltage, a little voltmeter, and you just measure the voltage at each one as you go across. And I'll tell you what's going to happen. The needle's going to say about 1 over here, because it's kind of further away, and it'll go to 2 here, and it'll go back to 1 over here. But there won't be any dead spots. There won't be any zeros. No zeros at all. None of that's going to happen. You're going to have a signal at all these locations, and you can even put a little light bulb on here, and you can have the light up. And the light's never going to go out, because these signals are still going exactly where you would expect them to go. They're plowing into this antenna, and as signal, as raw energy, they can be received as long as you're not tuning to a frequency. As soon as you tune to a frequency, your filter eliminates when they jam each other. So type the word jamming. That's what this is. Okay. So this whole implication that somehow these radio signals are interfering with each other, they're not. They're jamming each other. And there is no signal spots. This is a complete distortion of the reality. There's plenty of signal across the whole field, and there's just places where you could decipher it as 500 megahertz and places where you can't. because they're jammed. The two signals are on top of each other. You can know this kind of intuitively, that different radio stations can't broadcast at the same frequency because your radio can't decipher it. It can't receive the signal. So, I mean, another way of doing it, I would argue, is to tune to the higher frequency. Tune to the frequency. So first, tune to the correct frequency of 500. You'll get your on and off, on, off, on, off. So you get your bars. And then tune to that frequency doubled. And then see where those bars end up. And you'll see that they're going to probably be in exactly the opposite positions. So where the signal was off before, at 1000 hertz, it'll be back on again. And I bet you that'll be the conclusion. Like I said, somebody's probably got the equipment to do this, and hopefully I can find such a somebody. But I mean, it's not going to cost a fortune to do the experiment. But I'm just saying, it might as well be, why waste the resources for a one-time experiment? Not that I couldn't do other experiments with, let's say, a radio transmitter, but it just doesn't seem to me to be worth the effort. I was thinking I could just do it cheap, on the cheap, by getting a couple of MP3 FM radio converters, you know, ones that play your MP3s by broadcasting them on your radio. And those signals might be strong enough, maybe. But, you know, you have to have them kind of far apart to do the radio one, and so they might not be strong enough. So, you know, it might be a waste of effort. Might as well be done right, prove it once and for all, and be done with it. But it's just pointing out that I'm quite confident that this is the reality. This is the actual what's happening. It's just jamming the signal. It has nothing to do with wave interference. It's not actually happening. It's just putting two signals on top of each other out of phase and destroying the capacity of the radio receiver to receive the signal. But the signal is just as strong in the off spots as it is on the on spots. And it's just, again, they want to turn everything into, and you can see it in the way they construct the experiment. Like I said, I haven't seen the experiment done one time this way, where they just measure the raw energy coming from the transmitters. If you measure the raw energy, not specific frequencies, but just raw energy, I've never seen it done that way. So why is it always done with a carrier and the audio signal put on top? It's because that's the only way it works. And it only works because they're taking advantage of the fact that the two signals are jamming each other. Alright, so I think I've completed the task of this video, so to the point, short and sweet and whatnot. So anyway, till next time and such. So any contribution you want to make to a rational conversation, fine, but if you're just going to be an asshole, then that's what I'm going to treat you as.